It is both a very lengthy and probably the most important topic we have encountered so far, the production possibility curve, or PPC for short. Now, before we go into PPCs, we have to first look at this thing called the consumer and capital goods. Now, we have encountered capital goods before, so they are just human-made tools that aids in production, these machines. I won't go into that because we have talked about this before. And there is this new idea called this consumer goods. And this are goods and services that are produced by FOPs and purchased by consumers for their own satisfaction. So this just means what do we want? So essentially, what do we want? For example, ice creams. People want houses. People want cars. Everything that we desire and we want to purchase for our own satisfaction, that is called consumer goods. But anything that is related to production and not bought for our satisfaction, that is called the capital goods. All right, now that we have this clear, let's jump into our main topic of today. What is a production possibility curve? This is a very, very bad and long definition. So, a curve or line that shows the maximum output of two types of products and the combination of the products with existing technology and resources. So that is just a very long, bad definition. So let's take a look at this graph first. So from this definition, we already know that the PPC, it shows two types of products, right? So it has to be two types of products. It is also drawn on this kind of a graph. So it is drawn on this X and Y graph, and you have to label the origin here. And then there are two types of products. In here, we just use capital goods on our y-axis and consumer goods on our x-axis. It is also these existing technology and resources. So it's the only technology and resources we currently have. And we know that the technology and resources we have are limited. So there is a limited amount of goods and services we can produce because the resources and technology, these are limited. Therefore, we can show this maximum output of these types of goods and services through like a graph like this. It's kind of like a curve. And the reason it looks like this curve is because the more we produce, for example, the more consumer goods that we choose to produce, for example, at this point, we are producing more consumer goods at this point than at, for example, this point. The more consumer goods that we choose to produce, the less capital goods that we can produce. See, so here, from here to here, the capital goods that are produced decrease, while the amount of consumer goods increase. Therefore, it can be shown by this kind of a graph like this. And we'll explain later why this is a curve, not a straight line that goes down. So why it doesn't look like this. And so basically, the curve or line that shows the maximum output. So this line shows the maximum output that can be produced with existing technology and resources. And now there's this long-term vs short-term. So what does this mean? We know that these capital goods, right? We use capital goods to aid in production. We use capital to help us produce. For example, when farming, we use the tractors, cars or drones to help us get the seeds down. So capital goods, they aid in production. They speed up production and makes production faster and more efficient. Consumer goods, on the other hand, this thing is bought for people's satisfactions. So it is to satisfy people's needs. Satisfactions, right? Therefore, we know that if we want to produce more in the long term, we have to produce more of these capital goods. Well, why? Because they aid in production. So the more capital goods that we can produce, the more output we can have because they aid in production. However, if you want short-term growth, you can produce more consumer goods because they are bought for people's satisfactions, and this will encourage spending. We will talk more about this later. But for now, you can just know that if you want long-term growth, then you want to invest and produce more of capital goods. If you want short-term growth, you have to invest in more consumer goods. Okay, so the shape of a PPC. So we already talked about like the shape of it, right? So we drew a diagram and we knew that in our previous diagram it was in the shape of like a curve. Now there are two types of possible shapes of the PPCs. They don't always have to be curves. The first one is of course in the shape of a curve. But please remember, only can be this type of curve. It cannot be this type of curve. It cannot be any type of strange things like this or this. Only this type of downward bending curves. And the reason that it is in the shape of this weird downward bending curve is because the opportunity cost is actually not constant. So what does this mean? Take a look at this diagram. Let's say we are producing right now at this point, right, point A. And let's say on the y-axis we are producing good A, y-axis we are producing good B. So if we choose to produce more of good B, let's say we want to produce 1 times more of good B. Now we're producing at point big B. If you see the amount of good A we are producing, you will realize that the amount that we are giving up is actually increasing. So, to put it simpler, we are making a choice here, right? We are choosing to either produce good A or we are choosing to produce good B. We are making a choice to produce good A or choose to produce good B. In this case, we choose to produce good B, more of good B. There is an opportunity cost here. It is the next best alternative foregone, which is producing good A. Therefore, good A is lost. However, we know that this opportunity cost of losing the good A is not constant. We know that the more the good B, we want to increase its output, actually the opportunity cost is increasing as well. Because you see here, if we are producing at the start here, we want to increase the output by this much, we only lost a small amount of good A. But if we want to increase output by another chunk, so from here to here, we lose this small chunk, but from this A to this B, we're losing this huge chunk here that's bigger than the previous one. And if we want to increase it further, say from good B to point B to point C, let's say, we are losing this huge amount of good A as an opportunity cost. Therefore, opportunity cost is not constant for these downward bending curves. For straight lines, though, the opportunity cost is actually constant. So let's draw another diagram. If we have a straight line, if we are giving up, for example, we are going from here to here, right? The amount of this good A that we are giving up to produce more of good B is constant because it is a straight line. So this area here is the same as this area here. And then there's this shift in the PVC. Now, there are two types of shifts. So before we go into that, let's talk about what are even shifts. So here is your PPC. Let's draw as a curve. It's usually a curve. A total shift means an entire shift of the PVC. For example, shifting from here all the way to the outside. Now, why will it shift from here to here? For example, it's producing good A and good B again. Why is it shifting from inside to outside? There are two types of reasons. First is the quality of FOPs. If FOPs, so resources that we use to produce these products, the resources we use to produce good A and good B, if they suddenly become more efficient or their quality suddenly increases, then we can actually produce more of it at any given point because we know that its efficiency had increased. Therefore, it will cause an outward shift. The same with quantity. If we have more of FOPs, we have more resources, then we'll also be able to produce more of good A and good B. How about a partial shift? So that is total shift. How about a partial shift? A partial shift will look something like this. So we go from here to here. So this part doesn't shift, but the downward side shift. Why would it do this? Same again, good A, good B. First again is quality, but this time is not the quality of both good A and good B. In order to produce a total hour shift, the quality of FOPs to produce both good A and good B has to increase. For this, the quality of producing good A has to increase. But for good B, it does not change. No change. Only the quality of producing good, I'm sorry, I messed up. It's good B here. Only the quality of producing good B here is changing. Good A is not changing. Therefore, it will cause an outward shift in the B here. Now, if it will be a shift like this, right? If it goes up like this, then we know that the quality of A is increasing and B is not increasing. And same as quantity. If the quantity of the FOPs that produce good B is increasing, it will cause an outward shift like this. If the FOPs that produce A increases, the quantity of those FOPs increase, will cause an outward shift like this. And production points. We are very near the end. This is our last topic of the day. Production points. And what does production points mean? So it means a point on the graph that shows current level of production. Actually, we already used production points again before. And I explained like if we're producing at this point A. But what does this mean? This point A, for example, if I say that we are currently producing at this point A, this point A is a production point. And this A means that we are producing, for example, currently 100 units of this good B and 200 units of this good A. This is what A means. And for example, if I choose a point B here, that is also a production point, and that means the amount of good A can produce and the amount of good B it can produce. But besides a production point being on the curve or on the PPC, it can also be inside of the PPC. For example, it can be here. Production point C can be here, and it represents the amount of good B and good A it produces. So it is just a point on the graph that shows current level of production. It can be any point on or not on the graph. But then there is a separate difference. If, for example, you are like this point A or you are like this point B, you're producing on the PPC, that is called maximum efficiency. Because, well, we know that the production possibility curve is the curve that shows the maximum output of two products. Therefore, we are using the current resources and technology we have to its limit because we are producing on the PPC. Therefore, if points are on this curve, then they are in maximum efficiency. Have a spare capacity. When you are like this point, like this C here, you're spare capacity because you're not using all of your resources. And this is also called unemployment. If you are producing inside of the PPC, it will result in this thing called unemployment because we know that not all of the resources that we have are used in production. Because if all of the resources are used, we must be producing on this curve. And that is basically it. And let's look at some practice problems. We will do some more practice problems for this unit because it is obviously a little bit more difficult. First, the diagram shows a production possibility curve most likely to lead to a greatest outer shift of the PPC. Now, we already talked about the long term vs the short term. Now, we know that in the long term will cause greatest outward shift. The short term will cause a smaller outward shift. And the more of capital goods we produce, the easier it is to achieve long-term growth. The more consumer goods, the less likely for long-term growth and more of short-term growth. Because the capital goods can help us and aid in production. Therefore, we want to produce more of capital goods and less of consumer goods. And if you look at here, this point D is producing a lot of capital goods, but a smaller amount of consumer goods. So D is the answer. Second one, the diagram shows an initial production possibility curve of PPC1. What may cause the movement of the production possibility curve from PPC1 to PPC2? Now, we already talked about these shifts in PPCs. There are two reasons. First is the quality, right? First is the quality of the FOPs, of the resources that we use to produce the products. Second one is the quantity, the amount of resources that we have. You'll just write quant. And if you look here, a better educated workforce. That means the quality of labor is increased because we talked that workers are labor. When you think about labor, just think about workers. So the quality of labor increases, which means the quality of FOPs increase. This will cause an outward shift of the PPC. So A is the right answer. So another question here. 2014, private companies began to draw in areas of the country to exploit natural gas supplies that were known to exist. And how might this be represented on the diagram, which shows a PPC curve for a country? Now, this is a very, very tricky MCQ. So the keyword here is drawing areas of country to exploit natural gas supplies. First, they are trying to get more natural gas supplies that were known to exist. So now you would think, yeah, of course, exploiting natural gas supplies. Yeah, outward shift because quantity increase, right? Well, wrong. Because we know that the PPC shows the maximum output with existing technology and resources. If it is known to exist, that means these resources are already considered when constructing this PPC. Therefore, quantity is actually not increasing. Quantity of FOPs is staying the same because they are known to exist. Now, if it is not an hour shift, then what it is? What is it? Now we know that we are beginning to drill in areas, right? So obviously we know that we are spending and producing more of these gas supplies because we are beginning to drill in these areas to exploit more of these natural gas supplies. So of course gas supplies will increase, but there won't be an outward shift. So if we look at these options, the first from R to S, of course it is wrong. There are smaller amounts of gas supplies produced. From R to V, again wrong. We know that there won't be an hour shift because these gas supplies are already known to exist. So this is wrong. Moving from S to T, this is the most logical choice because we know that from here to here, the amount of gas supplies produced increases, but the amount of manufactured goods should also logically decrease by a little bit because you're producing more of these gas supplies. So you have less um, resources left to produce these manufactured goods. So C is the answer. All right, the last one of this very long and tiring unit. So which diagram shows an opportunity cost by movement from point X to point Y? Now, opportunity cost, movement from point X to point Y. So we know that opportunity cost means the best option that is forgotten, right? The best alternative that is forgotten. So let's just draw these diagrams. So at point X, you're producing these many, and point Y, you're producing this many. Does this show opportunity cost? Because we know that we are increasing both the output of these consumer goods and the capital goods. This does not reflect opportunity cost. And for option B, it's the same thing. It is not reflecting opportunity cost. You are producing more of both the capital goods and the consumer goods. But for option C, at point Y, we are producing a lot of capital goods but no consumer goods. And point X, we are producing a lot of consumer goods and less of capital goods. What does this show? This shows that in order to increase the amount of output of consumer goods, we have to give up our level of output of these capital goods. This is a reflection of opportunity costs because in order to increase the output of one, we need to decrease the output of the other. So this is a choice. We're choosing what to produce. The more of this we want to produce, the more of capital goods we are giving up. Therefore, the capital goods are the opportunity cost in this choice. So C is the answer. All right, that's it.